Today, we're tackling 5 questions for the Certified Kubernetes Application Developer exam, specifically under the domain of application environment, configuration, and security. Before we dive in, don't forget to subscribe to our channel and hit the notification bell. Now, let's get started. Here comes question 1. What is the primary function of a custom resource definition CRD in Kubernetes? A. To define new types of Kubernetes resources beyond the built-in ones. B. To configure network policies for pods. C. To create a new service account for a pod. D. To enforce security policies at the API server level. Absolutely, it's A. To define new types of Kubernetes resources beyond the built-in ones. CRDs extend Kubernetes by allowing users to define custom resource types. Let's tackle question 2. Which Kubernetes object stores sensitive information such as API keys and passwords securely? A. Config map. B. Secret. C. Service account. D. Network policy. Correct. It's B. Secret. Kubernetes secrets provide a secure way to store and manage sensitive data, such as passwords and API keys, preventing them from being hard-coded into application configurations. Here comes question 3. What does a Kubernetes service account provide to a pod? A. A unique network identity for external access. B. Permissions to access the API server securely. C. Automatic scaling based on CPU usage. D. Encrypted storage for application logs. Absolutely, it's B. Permissions to access the API server securely. Service accounts are used to grant pods access to the Kubernetes API. Let's tackle question 4. What is the purpose of the security context field in a pod spec? A. To define resource requests and limits for a container. B. To set security constraints like privilege escalation, user IDs, and capabilities. C. To schedule pods on specific nodes. D. To configure ingress and egress traffic policies. Correct. It's B. To set security constraints like privilege escalation, user IDs, and capabilities. The security context field allows you to apply security configurations at the pod or container level, such as running as a non-root user or dropping unnecessary Linux capabilities. Finally, question 5. What happens when a pod exceeds its defined CPU limit? A. The pod is automatically restarted. B. The pod is evicted from the node immediately. C. The pod is throttled, reducing its CPU usage. D. The pod is permanently deleted from the cluster. You nailed it. It's C. The pod is throttled, reducing its CPU usage. Unlike memory limits, which can cause a pod to be terminated, exceeding CPU limits results in throttling. That's all for today. Hopefully you found these questions helpful. If you want more exam questions, visit our official website, kubernotes.org.